Hi everyone, are you ready to build a robot? My name is Arya and I'm the CEO of Robotics Lab, and I'm dedicated to helping middle and high school students learn robotics through some really interesting and hands-on projects. I've been teaching this course for over 3 years in California, and I thought I would put it up on Udemy so that kids anywhere in the world can learn to become robot makers, because we need more makers in this world. So, if you are ready, let me tell you what we plan to build today. Our goal is to build an autonomous car using sensors and a microcontroller. Here's what the finished product looks like. Students from 6th grade to 12th grade have taken this course, and almost all of them have been able to successfully build this car by following the steps that I outlined for you. Along the way, you will learn 3 main things. 1. How to program an Arduino, which is a very versatile, low-cost, and easy-to-use microcontroller. You can think of it as the brain of the robot. 2. How to connect sensors to the Arduino and make the robot avoid obstacles. And 3. How to apply these concepts to complete mini challenges. Let's get started. I'm now going to go over the parts of the robot. Let me start with the chassis. Over here is the base of the robot. I've laser cut this triangular shape out of acrylic, but any rigid material, so long as it's roughly the right size, should work. This base is 4 inches wide by about 6 inches long. Up next, we have the wheels of the robot. These are laser cut acrylic as well, and they come with 2 rubber tires. Over here, we have the 2 drive motors for the robot. These motors connect to the wheels and help the robot move. Over here, we have the motor controller, and this allows you to control the motors through the Arduino. Over here is the ball caster and an accompanying dowel to attach it to the robot. And the ball caster is essentially like a third unpowered wheel for the robot. And the last chassis part, the servo motor. The servo motor is like the other 2 motors, but it only rotates 180 degrees, which makes it really good for an arm attachment for the robot. I'm now going to move on to the different kinds of connectors we'll be using. We have male to female wires, we have female to female wires, and male to male wires. And a breadboard that will hold all of the circuitry on the robot. Over here is the brain of the robot. This is the Arduino. This will hold all of the code, and it can be programmed from the computer with this USB cable. Up next is the battery holder. The battery holder holds 6 AA batteries, and you will use these 2 adapters to connect it to the rest of the circuit. Up next is the different kinds of electronic outputs of the robot. Over here we have the LEDs and the accompanying resistor that they use to ensure that they don't use too much power. And the next one is the piezo buzzer. This is like a little mini musical instrument. It can play different notes and even songs depending on how it's programmed. And lastly, I'm going to cover the electronic inputs or sensors for this robot. The simplest sensor is the push button. When it's pushed, it'll give a signal, and when it's released, it'll give the opposite signal. Over here, we have a potentiometer. The potentiometer gives a different signal depending on how far you twist the knob on the top. Over here, we have the photoresistor. This will give a different signal depending on how much light there is in the room. And over here is the line sensor. This is similar to the photoresistor in that it detects brightness, but it's much better at close range detection, whereas the photoresistor is more commonly used for ambient light detection. And lastly, we have this sensor, the ultrasonic sensor. This tells you the distance between the robot and an object, and it does this using sound. Sound waves will come out of the ultrasonic sensor, hit an object, and then come back to the ultrasonic sensor. And depending on the time they take to do that, the ultrasonic sensor can then calculate how the ultrasonic sensor and the Arduino can then calculate how far away the object is from the robot. And lastly, the one tool that you'll really need to put this all together is a hot glue gun. Hope you enjoyed.